Hi, welcome to this video tutorial, and today we shall be looking at what is called Pythagoras theorem. So Pythagoras theorem is a topic that lies under geometry. So geometry basically will be considering shapes and the relationship between sides and shapes. So Pythagoras theorem, named after Pythagoras, it is a theorem which shows the relationship between sides in a right-angled triangle. But before we actually explore more about the relationship between the sides of a right-angled triangle, let us consider a triangle that we have here. As a matter of fact, this Pythagoras theorem only applies to right-angled triangles. Let me write it down. NB. So the only time we are permitted to use the Pythagoras theorem, it is a case where we have a right-angled triangle. It is only used in right-angled triangles. So what do I mean by that? What we refer to as a right-angled triangle is a triangle in which one of the angles is a 90 degrees. As you can see, there's a symbol for a right angle here. It means that there's a 90 degrees in this triangle. So when you have that situation where one of the interior angles is a right angle, then you are at liberty to use the Pythagoras theorem. So we shall first name our sides. Then I've said hypotenuse is the longest side and it is opposite to a right angle. So this definition is actually very important when considering the Pythagoras theorem. There's a side which is referred to as the hypotenuse, and the hypotenuse is the longest side and it is opposite to the what? The right angle. It's always the longest side and it's opposite to the what? The 90-degree angle that we have here. So this is my hypotenuse, so shall abbreviate it as what? As hyp. Then apart from that, then the two other sides of a right angle triangle are named in relation to the angle that we'll be using at that moment in time. So remember, apart from using the 90-degree angle, we can have an angle on top here, then we can also have an angle below here. So if we are using this angle that is below here, the side which is adjusted to this side, which is connected to this angle, the side which is connected to this angle other than the hypotenuse, we refer to this as the adjacent. You can actually think of it as being adjusted to this what? To this angle. Then the other remaining side, this one which I have not named yet, it's opposite this angle which I'm considering in this moment. It's opposite to the angle I'm considering, so we refer to it as what? As the opposite. So a big takeaway here is that you have to know the definition of hypotenuse. Hypotenuse is the longest side in a right angle triangle, and it is also opposite to the what? To the 90-degree angle. Then the other two sides are named in relation to the angle I will be considering at the moment. If I'm considering this angle which is below here, this side, we refer to this what? As the adjacent, because it is connected or it is adjusted to this angle. Then the other remaining side, it's opposite to the angle that I'm considering, so it's opposite. But it's a different case. Like for instance, if I'm considering, let me say for instance, I'm considering this angle beta on top here. Say we are considering this angle and we are ignoring this angle that we have here. So once we have that situation, this side on top here, it is adjusted to the angle I'm considering. So the opposite becomes the adjacent. Then the adjacent here, it's opposite to the what? To the angle I'm considering beta. So it becomes the what? The opposite. So all in all, I can say, so in short, I can actually say the naming of the two other sides is dependent upon the angle that I'm considering. If I'm considering this angle, this side is adjacent. But if I'm considering this angle beta, this side is what? Is the adjacent. But the case we shall be using, we shall be using a case where we'll be considering this angle theta, which is adjusted to this what? To this adjacent. So what does the Pythagoras theorem state? So the Pythagoras theorem, it simply gives us the relationship between the three sides of a what? Of a right angle triangle. And it actually states that if you take the hypotenuse, then you square it, it is equal to the sum of the opposite squared plus adjacent squared. So this is what we refer to as the what? As the Pythagoras theorem. It was discovered by Pythagoras. It actually gives us the relationship between the hypotenuse and the opposite and the adjacent. If you take the hypotenuse, then you square it, is equal to the square of the opposite plus the square of the adjacent. So you have to memorize it. Hypotenuse squared is equal to opposite squared plus adjacent squared. And then the information that I have added here, I've said hypotenuse is the longest side and it is opposite to the right angle. Like I've said, it's the longest side and it's always opposite to the what? To the right angle. And then where do we use this Pythagoras theorem? Then I've said here, it is used to find a missing side in a right angle triangle when given the other two sides. So this equation is very, very important in geometry. As you shall see, we shall use it to solve so many problems. So you use this Pythagoras theorem to find a missing side. Like for instance, if we do not have the hypotenuse, but we are given the opposite and adjacent, we can use this relationship to find the hypotenuse. Similarly, if we are given the opposite and we are also given the hypotenuse and we need to find the adjacent, we can find the missing adjacent by making use of the hypotenuse and the opposite. So the situation actually works like that. When you're given two sides and you want to find a third missing side, you will make use of this relationship. So let's look at some examples and see how we can apply this information. In this case, as you can see, we have the first thing to note is that the triangle that here is a right angle triangle. So possibly I might use the Pythagoras theorem. So once you have that situation where one of the interior angles in a triangle is a right angle, you know that it's a right angle triangle. So you can possibly use what? Pythagoras theorem. Then the question that we have in this case, it is saying find A. We need to find this A, the A that we have here. So can note that we are given two sides of a right angle triangle. We are given this side and also given this side, and we need to find what? The third side. Like on this NB I've said, then on this NB I said it is used to find a missing side in a right angle triangle when given the other two sides. So that's the condition that we have here. So that's the condition that we have here. As you can see, we are given two sides of a right angle triangle and need to find a what? A missing side. So the first thing to do is to name your sides. You have to name my sides. So we start with the longest side and it's opposite to the right angle. We refer to this as the what? Is the hypotenuse. That I've named that one. Then after naming that one, we then name the other two sides. So considering this as the angle of consideration, we shall take this 4 as the adjacent. This is the adjacent. Then finally, if you're considering this angle, this becomes the what? The opposite. So this is my opposite. So I need to find the hypotenuse, but I'm giving opposite and adjacent. So we write our Pythagoras theorem. Our Pythagoras theorem simply states that the hypotenuse squared is equal to the square of the opposite plus the square of the adjacent. After doing that, we then substitute our information in the formula. So we have A. So for hypotenuse is A, so I will have A squared is equals to, then the opposite is 3, then it's 3 squared plus, then adjacent it's 4, adjacent 4, then we have 4 squared. Then after writing that information down, we then simplify. So we have A squared is equals to, then 3 squared is the same as saying 3 times 3, and that's 9 plus, then 4 squared is 4 times 4, then we get 16, then we have 16. Then I'll add here 9 plus 16, that's 25. That's 25. So to get rid of this power 2, I multiply by power half on both sides. So I'll multiply by power half here, then also multiply by power half here. So 2 and 2 here will cancel, then I'll be left with A is equals to 25 to the power half. So using the laws of a fractional power, what it simply means by saying 25 to the power half is the same as saying square root of what? Of 25. Then if I look for the square root of 25, it's actually 5, because if you multiply 5, we get 25. 5 times 5, that's 25. So which means the dimension of this A is actually 5. So since the other sides are given in meters, so which means my A is actually what? 5 meters. So basing on the Pythagoras theorem, we can conclude that the hypotenuse, in this case this A, is actually equivalent to what? To 5 meters. Then we'll be done dealing with this situation that we have here. So let's move on to the second example. And the second example that we have here, it's a bit advanced than the first example. It is saying question 2. So question 2, we have this diagonal that we have here, PQRS, then find x and y. We need to find the value of x and the value of y. So basically what we can do here, if we consider this triangle, let's consider this triangle first, PRS, ignoring this other part. So if I consider that, you can note that we have this side missing and also this side missing, and they're only given one side. So we cannot start by this triangle, because if we start with this triangle, we have a situation where we have two unknowns with one equation, and we know we will not be able to find what? Any of those two values. For you to find the value of two unknowns, you must have two equations to solve that question. So which means we shall start with this triangle PQR. So for triangle PQR, you can know that it's a right angle triangle, and you are given the opposite and adjacent, and you need to find the hypotenuse. So we can actually apply the what? The Pythagoras theorem. So let me do that. Okay, so starting with this triangle PQR, as you can note, we can actually label our sides. So we'll start with this longest side. So this longest side, as you can see, it's opposite to this right angle, so we call it the hypotenuse, and it's the longest side. And then we have this other side. This one becomes my opposite, and this is my adjacent. Then after labeling my sides, I can now find the missing value y, because I have two sides of a right angle triangle, with the third one being the missing side. So Pythagoras theorem simply states that the hypotenuse squared is equals to opposite squared plus adjacent squared. Then I can feed this information in my formula, put this information in my formula. For the hypotenuse, it's y, so I'll have y squared is equals to opposite, it's opposite, that's 3, then that's 3 squared plus, then adjacent, that's 2, then I have y squared is equals to 3 squared, that's 9, plus then 2 squared, that's 4. Then after doing that, we have y squared is equals to 9 plus 4, and that gives me a 13. Then I'll square this side, then I'll also square this side, then I'll be left with y, then square and this will cancel. Y is equals to square root of what? Of 13. Then I'm done dealing with that part. Then y is equals to square root of 13. In other either write this as a decimal, but I shall leave it in set form. Then after doing that, we then go to the other remaining part. We are now left to find what? The value of x. So since I now have the value of y, in this case, we can actually call this y is actually root 13. Then I now have two given sides. I have y and I also have 6, and I need to find the value of x. So we name our sides first. We start with the longest side. So this longest side is opposite to this 90-degree angle, so we call it the hypotenuse, and it's the longest side. Then 6 is adjusted to this side, so it becomes my adjacent. Then finally this other side is opposite to the opposite angle of consideration, so it becomes my opposite. So take note here, on this triangle it was the hypotenuse, but on the other triangle it's no longer the hypotenuse, but it's rather what? The opposite. So we write our Pythagoras theorem. Our Pythagoras theorem simply states that the hypotenuse squared is equals to opposite squared plus adjacent squared. Then the hypotenuse, in this case the hypotenuse is x, so I'm going to write my x squared is equals to, then the opposite, this time around the opposite is square root of 13, so we have square root of 13, then I'm going to square it plus, then adjacent it's 6, then we have 6 squared. Then moving on, I'll have x squared is equals to, then square root of 13, remember square root is to the power of what? Of half. Half and 2 will cancel, then I'll be left with 13 here. You can actually verify this by a calculator. If you say square root, if you say square root of 13, then you close the bracket, then you close the bracket, then we square it, you will simply get what? 13, because square root of 13 simply means 13 to the power half. Then half times 2, I'll get 1, so it's simply what? 13. Then 13 plus, then 6 squared, that's 36. Then you have x squared is equals to 36 plus 13, that gives me a 49. So this is my what? My 49. Then to remove this power 2, we multiply by power half. It's the same as squaring here, then squaring here. Then square and this square root will cancel. Then I'll be left with square root of 49. Then square root of 49, that's 7. Positive 7 self multiplies. It gives me 49. 7 times 7, that's 49. So x is equals to 7 centimeters. Then 4, then here is 7 centimeters. Let me actually change it. This is 7 centimeters. Then this is square root of 13 centimeters. So this is what? Centimeters. So basically, that's how we make use of the Pythagoras theorem to solve problems involving right angle triangles. So this marks the end of our lesson. Thank you.